Subscribe to the Global War Archive right now if you value serious evidence-based history, because what we're about to cover is not lifestyle trivia or romantic nostalgia. This is hard-earned environmental knowledge that kept entire civilizations alive long before electricity, HVAC systems, or industrial materials existed. Medieval builders solved problems we still struggle with today, and they did it using stone, wood, wind, water, and an intimate understanding of climate. If you care about resilience, sustainability, or how society survives stress, this topic belongs in your toolkit. This opening matters because medieval climate control wasn't accidental or primitive. For the next minute, I want you to focus on one uncomfortable truth. Modern buildings consume enormous energy to maintain comfort, yet many fail during power outages, heat waves, or fuel shortages. Medieval structures, by contrast, regulated temperature passively for centuries, often in harsher climates than ours. These weren't lucky accidents. They were the result of observation, generational knowledge, and ruthless trial and error. When you stand inside a medieval hall on a hot day and feel the air remain cool, you're experiencing environmental engineering refined over hundreds of years. That's the foundation we're about to unpack. And once you understand it, you'll never look at stone walls the same way again. Medieval builders understood thermal mass better than modern developers do. Stone was not chosen simply because it was available. Medieval architects understood that thick masonry absorbed heat slowly during the day and released it just as slowly at night. This created stable interior temperatures regardless of daily swings. Structures like Mont Saint-Michel or English keeps were deliberately overbuilt by modern standards because mass was insulation and climate control rolled into one. The practical lesson here is straightforward. If you're designing or retrofitting a building today, prioritize dense materials in interior walls and floors. Even concrete or brick can replicate this effect if positioned where it absorbs sunlight during the day and radiates warmth after sunset. Orientation and sunlight were calculated with precision, not guesswork. Medieval architects paid close attention to the sun's path across the seasons. South-facing walls captured winter light, while minimal openings on northern exposures reduced heat loss. This wasn't aesthetic tradition, it was survival math. In monasteries such as Cluny Abbey, living quarters were aligned to maximize passive solar gain during colder months. You can apply this today by placing frequently used rooms on the sun-facing side of a structure and limiting glazing where heat loss is highest. Even a small change in window placement can reduce heating needs dramatically. Ventilation systems worked with wind, not against it. One of the most misunderstood features of medieval buildings is their height. Towers, clerestories, and high ceilings weren't only symbolic of power or faith, they created vertical airflow. Warm air rises, and medieval builders exploited this fact centuries before fluid dynamics had a name. High windows and roof vents allowed hot air to escape, drawing cooler air inward at ground level. Castles like Crac des Chevaliers used cross-ventilation to remain habitable even in Mediterranean heat. For modern application, the principle is simple, really. Create low intake points and high exhaust points. Stack ventilation still works whether your building is medieval stone or modern steel. Courtyards functioned as natural climate engines. In hot regions, enclosed courtyards acted as thermal regulators. During the night, stone walls released heat into the open air. During the day, shaded courtyards remained cool, circulating air into surrounding rooms. Water was used as an environmental tool, not decoration. Medieval fountains, cisterns, and channels weren't ornamental luxuries. Flowing water cooled surrounding air through evaporation. In fortified cities and abbeys, water features were deliberately positioned near living quarters. The sound may have been pleasant, but the cooling effect was the real prize. Medieval insulation relied on layering, not synthetic materials. Walls were often composite systems. Stone on the exterior, rubble or air gaps inside, and wood or plaster internally. This slowed heat transfer and controlled humidity. Why this knowledge still matters in a fragile world. Medieval climate control was decentralized, repairable, and resilient. It didn't rely on fragile supply chains or constant energy input. When systems failed, people adapted rather than froze or overheated. That's a lesson modern society is relearning the hard way. Studying these buildings isn't academic nostalgia, it's disaster preparedness, sustainability, and long-term thinking grounded in history. If this kind of serious, practical history is why you're here, subscribe to the Global War Archive and share this episode with others who care about how civilizations actually survived. These lessons endured for centuries, and they're worth preserving.